Today we are going to take a look at section 7.5. We're going to spend 2 days. Now in section 7.5 we learned to solve exponential and logarithmic equations. Today we're just going to take a look at exponential equations. So when you're all done today, you're going to be, today we're going to look at how to solve exponential equations. And when we're all done today, you're going to be able to solve the problem like what I've shown right there. Alright, I have 3 problems that I want you to pause it and work through these, and then we'll talk about them here in a moment. Okay, now that you've looked at these, first of all, what did you do? You have log base 16 of x equals 3 halves. Now, you want to decide, what will x be? How are you going to handle this situation? I would handle this situation by changing it from log form to exponential form. So, as you did that, you're going to get 16 raised to the 3 halves equals x. You can enter that into your calculator if you desire, and your answer will be 64. Okay, the next one the same. You have changed the next one to exponential form. X to the third equals 1.3331. And here was your answer. Let me just uncover this here. Okay, you got 1.1. Okay, and for the last one, remember right here you have a base 10, and you can change this into 10 to the 4th. So it logs out, and you're left with x equals, you said it, 4. Okay, let's begin today. Okay, getting to this, let's talk about what an exponential equation is. An exponential equation is an equation containing one or more expressions that have a variable as an exponent. Now, in order to solve an exponential equation, these 2 properties here are very important. Okay, or should I say this one property is very important. Now, look right here. You have b to the x equals b to the y. Now, if your bases are the same, then your exponents must be the same. So if b to the x is equal to b to the y, then x equals y. Now there is a restriction, of course. Likewise, if you take here, if I have if I have a equals b, then that means the log of a is equal to the log of b. And there are some restrictions there, of course. A and b have to be greater than 0. So, in looking at this here, we're going to use these properties here to solve for exponential equations. Now let's begin looking at the first one. For the first one, it says you have 9 raised to the 8 minus x equals 27 to the x minus 3. Now, what I want you to look at here is, let's see if there's some way that I can make this the same base as this. Because remember, according to those properties that you just wrote down, if the bases are the same, then you can set the exponents equal to each other. So here's what it's going to be. We can write the 9 as 3 squared. Okay, so you're going to have 3 squared. And you can write this 27 as 3 to the, third. Okay, so we have that. Now, let's change this out just a little bit, because I can move those parentheses just a little bit, and it's going to look something like this. Now, what did I just do? Well, I distributed this 2 to the 8 and the 2 to the x, and then I distributed this 3 to the x and 3 to the 3, and that's how I have here. Now, notice, my bases are the same. So because my bases are the same, I can set the exponents equal to each other, and I'm going to get an equation that looks like this. And then after that, we can just add 2x to both sides and add 9 to both sides. And you are going to end up with a 5x. Let me write that down here. You're going to end up with a 5x equaling 25. Divide by 5 on both sides, and you end up with x equals 5. Now let's go through and check our work. So we're going to take this 5 and I plug it in. We simplify that. Gives us 9 to the third equals 27 squared, which gives us, does it work? Yes, it does work. So our solution is x equals 5. Now take a look at this one here, and I want you to see in this one here, you can't quite do what we just did. Why? Because can I change this right here? Well, I can go 2 to the second power here, but this 5, no, I can't do anything with that. Okay, so what we're going to do here is we are going to take the log of both sides. Okay, now, what am I going to do with this log of both sides? Well, let me rewrite this here so I have a little bit more room. So I have 4 raised to the x minus 1 equals, and I'm going to put the 5 there. Now, I want you to see this base right here. You see how this base is a 4? I'm going to take the log of both sides, and I'm going to let the base of my exponent be equal to the base of this log. Okay, so in doing that, so let's go ahead and do that here. So I am going to take log base 4 of this side. Now whatever I do to the one side, I need to do to the other side. Now notice when I did that, notice what happens with this. The base of the exponent is the same as the base of the log. So this logs out, and I'm left with x minus 1 equals log of 5 base 4. If I add 1 to both sides, I will get x is equal to 1 plus log of 5 base 4. Now to handle it from here, we need to use the change of base formula on this piece right here. So, because I'm going to enter this into the calculator and I want an approximate answer. Okay, so here's what we're going to do. So I have x is equal to 1 plus, and the change of base formula says I'm going to get the log of 5 divided by the log of 4. And when I enter that into my calculator, I will get this for an answer right there. Okay, now to verify that, let me uncover what I have underneath this little oval. And this is what it'll look like with your calculator. So you're going to take your calculator and you're going to plug it in to check it. So normally here, notice you took this here, you plug it into the original equation right up there, 4x, right there, and you end up getting 5.0024, and it's equal to 5. Now you're saying, what about that 0.0024? Well, guys, remember we had to do a little rounding right here, and because we did rounding there, that's what took this off just a little bit. So there you go. For this next problem, we're going to do this problem 2 ways. Now, and it's completely up to you how you want to do this. So if I have 3 raised to the 2x equals 27, notice if I look here, this is 3. Can I change this 27 to like a 3 to the some power? Yes, you can. So this is one way of doing it. So you can take this and be 3 raised to the 2x is equal to 3 to the third. Now, notice, your bases here are the same. So since your bases are the same, you can set your exponents equal to each other. So you are going to get a 2x equals a 3, or x equals 3 over 2. Alright, so now remember, when you do that, because you're solving for it, make sure you put your answer in set builder notation. Now that is one way you can do it. You can also take the log of both sides. Okay, so it's whatever method you want to do, and I'm perfectly okay with you doing it either way. So let me demonstrate it, taking the log of both sides. If I say 3 raised to the 2x equals, and then let's put a 27 there. And what you're going to do is you're going to do a log, and because the exponent is a 3, you're going to make the base of your log a 3 so that this logs out. So you're left with 2x on this side. On this side you have log base 3. And remember, ask yourself right here, 3 to the what power is 27? And of course you say it's going to be a 3. So you put a 3 there, you divide by 2 on both sides, and you get x is equal to 3 over 2 as well. Alright, so for this problem here, matter of fact, for all 3 problems that we played with so far, you can use either method, whether you want to use this method here, method 1, or you can use method 2, whichever floats your boat. Alright, let's move on to the next slide. In this next slide, we took our answer and we plugged it back in. So make sure you take your answer, plug it in quickly, make sure it works. It does verify, and you get your answer. Okay, 3/2 or 1.5. We are almost got this wrapped up for today. But let's go ahead and look at where we can apply what we've learned today. So first of all, it says, suppose a bacteria culture doubles in size every hour. Now, if it doubles in size, that means our R value is going to be, well, it says double, so that means it's going to be 2. It says, how many hours will it take for the number of bacteria to exceed 1 million? Okay, now let's think about a formula we already know. Remember, we have something like A of, and you decide your variable. We could use N, we could use T, we could use X. I'm going to use N today because we're talking about the number of bacteria. So I want the A of N is going to equal, and let's see, we start out with 1 bacteria times, it's going to double, and it's going to be raised to the N. Okay, so looking at that, now it says right here, it says it wants it to exceed. Now let's simplify this here. If we simplify this a little bit, and I'm going to flip it over as well because I want to put this piece right here on the right side. So that means it's going to be 2 to the N, and it's going to exceed 1 million, so it's got to be greater than 1 million. Now instead of putting a 1 and writing all those 0, I'm going to go 1 times 10 to the, and let's put it in scientific notation. So remember how we do that? Our decimal's here. 1, 2, 3, 4, 5, 6. Alright, so we're going to put to the 6th power. Alright, now let's stop there for a second and let's see if we agree with what we have done. And do we agree? Yes, we have. So we're going to solve that. Alright? Now, notice here, you may be saying, oh, what's this here? I see 10 to the 6th and I see 1 times 10 to the 6th. Well, let me ask you, what is 1 times anything? Is it that same anything? Yes, it is. So I can just write it as 2 to the N greater than 10 to the 6th. All right, now we're going to look at this and we need to get the solve for N because I want to know the number of hours, how many hours it's going to be until we reach 1 million bacteria. All right, so in doing that here, can I make this right here, look at this 10, can I make this 10 be 2 to the something power to give you 10? You're right, the answer is no. So look at this base here, it's a 2. So I'm going to take the log of both sides. So I'm going to take the log base 2 of this side, and I'm going to squeeze it in here, log base 2 right there. Okay, now in doing that, notice what happens right here. This logs out, and I'm left with N greater than, and I have log base 2 of 10 to the 6th. Now, we're going to need to simplify this piece of it right here. So how do we simplify that piece? Well, first of all, let's push this up a little bit so we can have some room. And let's remember our power property for logs. Our power property for logs says I can take that 6 and pull it out front. So it's going to be 6 times the log of 2, or the log of 10 base 2. All right, now, to handle this piece of it, we need to use our change of base formula. So it's going to be 6 times, and I'm going to use just the common log, so it's going to be the log of 10 divided by the log of 2. And of course, so the number of hours will be greater than that value. Okay, now from here, what do I need to do? Well, let's give us some more room. You're going to plug that into your calculator, and I want you to go ahead and do that. You plug it into your calculator from this point and tell me what you get. And what I want you to do here is I want you to write it as a sentence. Okay, so you're going to have N greater than whatever that comes out to be, and you're going to find that on your own. And then you're going to write your answer as a sentence. Okay, let's see how you did. Okay, when you plugged it in there, you should have got something like 19 point some odd, like 19.931568, and the decimal just keeps going from there. Okay, now we're going to just round, for the sake of time here, because this is in hours, we're going to round this to 20 hours. Now, what about, just for curiosity's sakes, how many bacteria are we going to have in 20 hours? Well, you're going to take that 20, plug it into the original equation, and you're going to see just how many. So it's going to be 2 raised to the 20th power. Okay, so when you go 2 raised to the 20th power, that will give you approximately this many bacteria. So in 20 hours, there will be 2 to the 20, or 1,048,576 bacteria. Here is our assignment for today. So we're going to do section 7-5, day 1, and please write down this problem set. Okay, I will see you in class, and have a great day.